Okay, so today we'll do Nmap, end-to-end in a tutorial, you can say. But before we do Nmap, so we should understand there's a concept of ports. Let's say we call virtual ports. So let's understand virtual ports. So basically, every device, every computer has some virtual ports. So ranging from 0 to, let's say, I think 65,536 or something, which means port 0, port 1, port 2, all the way to port 65,536, something like that. So what this virtual port means, for example, in my computer, there are many applications, let's say. So there are many applications. I can open YouTube. I can open this database application. I can open this. I can open this. I can open this. So when I open everything, the data is coming to that particular app only. If I open YouTube, if I click a video, the video will play in YouTube only. Parallelly, I can open music also. For example, I can open music. I can listen to the music. I can open a video. In a way, all these things can run parallelly. Each app or each service, let's call each program, or service will have a port. So maybe this music, example, this music. So when I click on play, it will play these songs. Maybe this music app is running on, let's say, port number, example, I'm just making up 456. Example, I'm just making it up. Maybe another YouTube, there is a YouTube app example. Maybe that YouTube app, it's whatever it is. It's running on something like, I don't know, 678, something like that. So actually, these are the virtual ports. All these are virtual ports we call. Every program, every service you do in computer will run on some port, any port, like unique port, of course, out of 0 to 65536. In a way, you can think like this. Your IP address tells you the, let's say, this computer IP address, think like a street. MAC address is apartment or building, perhaps. Port will tell you exact floor or room number, something like that. Anyway, you can think like this. IP address means you can, like a street, a piece of area. MAC address means a particular apartment. Port will tell exact which room number is. That means, hey, in this street, in this apartment, in this room, I have to go. Just like your address, right? Your address has street name, maybe building, apartment name, or something like that. If the apartment has multiple floors, example, maybe floor and exact room number, something like that. Let's say when you open YouTube, example, youtube.com or YouTube, you're listening to music or watching some video or whatever. That means the video data is coming to that particular IP, that particular MAC address, and that particular port. So that is how each program or each service works on every computer. Obviously, everything requires internet mostly. So whenever there is internet, I mean, whenever you want to fetch some data from internet, they follow this procedure. Even websites also, if you go to websites, if you type google.com, example, so they usually hide the port, but you can try this also. You can give this column, you can give like something like 80. 80 is a port number. If you run, you can say you can still get the Google. So usually they hide it. They hide this one, but you can try both. Just a second. Yeah, 443. There are two ports, 80 and 443. So we call HTTP, HTTPS. Like every website is pretty much HTTPS only, which means this HTTPS is running on, it's a program, it's running on uh, uh, 443 port. It's by default, it's 443. Maybe there is another service called HTTP service that will usually run on 80 port. So some ports are fixed actually. We fix some ports for specific applications. Some ports are random. I think first thousand, let's say, are very common ports, most common task, like maybe watching something, browsing, file transferring, all these are common tasks. Maybe first 1,000 ports are very common. Maybe these other ports are for some other applications like. So it depends. Like. So in computer, most of the ports are closed. I mean, okay, maybe I'll tell you this. So the status of the ports. Yeah, any question up to this point? The ports, just ports. So just recap, every computer has virtual ports. Virtual means not real, virtual, like the port range from 0 to 65,000. You can pick up any port number. If it's not running any program, you can run a program on that port. Pretty much every computer and every program, every service will run on a port. Example, music app is running on this port, YouTube is running on this port. Example, I'm just making it up. They're not exact same, but port numbers might different. But you know what I'm saying. It's like this. IP address tells you like street, MAC address tells you like apartment. Port actually tells that, hey, which room I should go, or which program I should give data, or I should run this, something like that. So yeah, something like the top 1,000 ports are most common applications, services, let's say. Maybe some other ports also, like, I mean, we can see actually. Let's open, just a second, this is a different browser. Uh, so if you look at virtual ports, uh, okay. You can see it's a logical virtual connection used to identify specific process or service on the device. So they're virtual. They don't represent physical. Physicals like components, like sockets and everything. They're virtual. Like a number identifying specific process. Yeah, that's what port is. You can see. I can see the range is 0 to 535 actually, not 6. 535. So that. 0 to 102 for well-known ports. You can see there is a service called HTTP. There is a service called HTTPS. These are networking services actually. Because if you allow this, if you stop these two ports, you will not access browser. I mean, if you're a server, but we'll see. So these are some registered ports. For example, if you use any database, the database runs on 3306. Postgres SQL is also database. It runs on 5432 or something like that. So these are some dynamic, these range is dynamic private ports, mostly OS for temporary connections, like temporary services or something. This is what exactly they're telling. You can see IP address is street, MAC address is like apartment, port number is like exact apartment number or room number or something like that. This is what exactly they're telling. You can see when you google.com, your system connects to their IP and specific port 80, and that's how you get the answer. 80 for HTTP, 443 for HTTPS. I will see why ports are important in cybersecurity. So maybe small thing you should know, like ports have a status, something like this. Ports have a status. It's like a switch. Switch means like a power switch. It's either open or close, like a switch on or off, something like that. So every port is either two options, either open or close. You can open a port or you can close a port. Typically, in any device, most ports are closed. No, typically closed. Maybe some ports are open for some services. Some ports are open for some services. Some services. Right? For example, let's say I have a database called PostgreSQL. This one, pgadmin or something. It's a PostgreSQL. So to run this database, I need to open. By default, it's I think I forgot the name 5432. So I have to open this port. If I don't open this port, this application won't run. Or I can change this application port to something else, but I should open that port. Okay, I have a question how ports helps in cybersecurity. It's like this, right? Yeah, maybe you'll see. First, you understand status, either open or close. So if the port is open, example, if the port is open, anybody can send some information, some data, some data via that port. So if the port is open, let's say one port is open, so anybody can send some information. So think like an attacker. Let's say you are an attacker, you have a system, I mean, not somebody's system, and you think that there is a port open in that system, one port. So you can send some virus example via that port. That means you can send that virus from your computer to their computer via a particular port because that port is open. So that's how attackers attack computers or devices or whatever. If the port is closed, of course, the attacker cannot talk to uh, that particular device via that port. So usually the attacks happen on the ports. So attackers at least identifies open ports and try to send the data. So that is where Nmap comes. Nmap we'll see. Nmap is used to gather the information about which ports are open in other computers, which ports are closed. So you will at another computer you will study like which ports are open, which ports are closed. So if there are any open ports, you'll try to inject some virus or something. I mean, depends on the interest. So that's why ports is important for cybersecurity. Networking, like yeah, I think that's all about ports actually. I think mostly is that only. We need to know what is a port, what is the status of the port, uh, most common ports, yeah, something like that. So as I told you, most ports are closed in any computer, even your computer, any computer. But some ports are open for some services. Just like this one. Now I open pgadmin. So pgadmin will run on port. So let's see. It's 5432, I think. Something. So I can check. Let's see. Check if my 5432 open on my own Mac. That's it. Copy. So I'll just open terminal. I just want to check it if it's open or not. I'll paste it. Yeah, you can see it. The port is running. Port is open. PostgreSQL is listening. If I stop this port, then I cannot use this database thing, because this database will run on that port. For example, I can run a command. I just want to show you only. So where is that query? Let's query. Okay, let's copy to query editor. That's fine. Okay, I'm just getting some data from database. Now I'll turn off the port. Stop the port. Close the port. Yeah, I have to stop the Postgres directly. Okay. Hmm. I can do this also, but it's like a rule and everything. Let's. So it will stop the port, and I cannot run this Postgres. Okay, successfully stopped. It automatically will open actually. It's like systems will do it. So let's see. Yeah, it's automatically will open only. Maybe this is not a. You can try light exam, but generally I just think like you can close a port or you can open a port. So let's use Nmap now. Let's try to understand Nmap. That's all about the ports mostly. Yeah, any question? Okay. So let's use Nmap. So I'll tell you Nmap is mostly used for information gathering. It's called information gathering. Like gather information about other devices. Other devices. Like typically, let's say before you attack somebody, you gather some data about them, right? Hey, like it's simple. Hey, what are the name? Where do they live? What information they have in real life? So typically here also in cybersecurity space also, typically attackers when they want to attack somebody, they learn usually about their device information. Like maybe they will learn about where they are. Let's say if you know their IP address, example, you can learn about which ports are open on the computer and which operating system they use, which services are running, which software is installed with versions and everything. Maybe they can even do like geolocation. I mean, they can do a lot more stuff actually, but these are some of them we can try. Which ports are open, which operating system, whether oh, they are active or not. Something like that. I mean, I think that these are very commonly used things. But you could do a lot more. You can write some scripts if you're into programming and stuff. You can inject some scripts in their computers and see how it's reacting to it. Of course, firewalls blocks it from their computer, but imagine that. So that's what Nmap is used mostly to gather the information. It's not about attacking. I mean, you're not attacking them or anything, but you're just uh, like in a way you're pinching them and see how they are reacting. You're hoping that they will reveal more information about them. So that's what Nmap is. You can use that information to attack also, but in a way, Nmap is not like you're attacking some computer or anything. You're not doing any damage to them, but you're gathering as much information as you can from them. So that's what is mostly Nmap is used for. It's open source too. You can go click Nmap, let's say, download. Yeah, it's open source. You can click on Nmap download. Just download whatever operating system you have. Already downloaded. I already installed it. So I think it's already active. Let's try it. Yeah, it's already installed for me. If you want to install again, go to this site, just choose your operating system and maybe follow your, uh, yeah, yeah, you can use in Windows, you can use in Linux. Linux, you can maybe take the latest one, this one. Or if you have Windows, you can directly take the so Windows is not there, so it will be there, right? Yeah, somewhere it might be there. Just check it. Yeah, it might be there. I have Mac actually, so I directly download. What I did is, yeah, it's there. You can see it. You just have to follow some things, mostly like, yeah, maybe you go through it. If it's not happening, I'll see it. Uh, but in Mac, it's very easy. I'll just download this file. Windows executable. Yeah, you can see, right? Windows executable installer. You can click on it. Okay. This one, exe. Yeah, this one, exe file. You download it, you run that like. So right now I have a Mac, so obviously this won't work for me. But similarly, I can go for my Mac OS. I can download this .dmg. You can download, if you're Windows, you can download .exe. If you're Mac, you can download .dmg. And just click next, 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 like basic installation only. If you're Linux, let's see. So Linux, you have packages. Maybe you can go to terminal. Uh, you can kind of you see this one RPM. Just download this one .rpm. Yeah, something like that. I'm sure it's easy only. It's not that difficult. Uh, yeah, once you download, once you install, let's say this is Mac. I'll just click on it. So I'll just open install, double click. I can say just install something like this. This. I already there, so I'll just stop it. But it's already there for me. So once it install, just check Nmap. You will see options and everything. So that means it's installed. You can see they give you some yeah, you can see some things you can do. You can host discovery, you can scan techniques, you can scan ports, you can you can run some scripts, you can detect their OS, you can even check their firewall and to see how it's behaving. Yeah, you see all these are doable things. So anyway, we'll do a few things. First is let me get my IP address. Uh, so let me see my IP address. My IP address is, what is that? Sorry, I have to read, but I'll just barely get it from Wi-Fi. Okay, it's 1020. So it's a private IP, not public IP. Okay, 102. It's fine. Okay, so I'll tell you the commands. So the first command probably you'll do nmap. So there is a flag called SN. SN means scan, no ports, simple scan. So I'll just give you my IP 92.168.0.10. Maybe I'll just save these things. You can go watch later. To check if it's active or not. Okay, you can see and map done. IP address one host is up. One host is up means hey, this IP address is active. which means the device is running on this IP. So let's try another IP, 103. Okay, 103 also is running. So 104. 104 probably not running. Okay, you can see 0 or stop. That means this IP address is not active, or there is no device with this IP. So it does simple scan to just check if that particular device is up or down, or up or not up, like down, let's say. So that is what this command does is. Or you can check the entire subnet. Subnet means like this. That means it will check all the IPs. Check this IP, it will check this IP, it will check this IP, all the way, it will check this IP. All these IPs it will check. It will tell me which IPs are active, which IPs are not, if I run this command. Only difference is this extra /24. /24 means first 3 bits are fixed, change only this. So that's subnetting concept. I think we already saw previously. I'll just copy it. I'll just clear it, paste it. So I'm checking the entire subnet now. So it will scan every IP, this IP, this IP, this IP, all the way to this IP. And it will tell me which device is active or which IP is active. And the subnet tells me which device is active or up. I think it will take some time because it has to scan every image. You can see 4 O's up, 01 up, 101 up, 102 up, 103 up. That means this is my router, Wi-Fi router, not a computer, it's just a router. These three probably either computer or phone, something. Of course, this is mine. See, the other two might be my phone. I have another computer. It's Windows. I turn it off, but maybe I'll just have to check it. Maybe this is that IP. Up means it's run. Up means the computer is active, like it's on, like so the computer has that IP. If the computer, like if I shut down this computer doesn't have any IP, so it's down. But if I leave like this, like I'm not doing anything, but it's just there, so that means up. Or if I turn off the Wi-Fi, or if I'm not connected to any network, then of course it's down only. So as long when IP address is active, that means it's connected to a device. That's what up means. Like if I shut down the computer, it's down. Or if I close all the ports, like if I put an airplane mode, that means that IP is not up. Like yeah, that's a simple command to check. Now let's try to see which ports are open in my device and other devices. So there's a command like p/ this one, and then I'll give my IP, something like this. Hold on. So this will scan all the ports 0 to 65,000 and tells me which ports are open, which ports are not. So let me run it, copy, clear it, paste. It's my computer only. You can see these are open. 80 is open, 88 is open, 445 is open, 5,000 open. You can see these services running, some Microsoft DS service, some unknown service running, but these are open. Remaining 65,000 are closed. So this IP in my device, these ports are open. The rest of the ports are closed. So similarly, I can scan the entire subnet by giving 24. Now it will scan all the computers in that subnet, and it will tell me which ports in open in all these computers, which ports are not. You mostly want to look for open ports only because most ports are closed. Yeah, let's try it. Yeah, it is started. So it will scan all the computers, mostly whoever is active. It will scan their ports, all ports, and tells me which are open, which are not. So while that is running, I'll tell you a few things. You can also look for specific ports, something like this, as I want to check if 80 port is open on my computer. That's a specific. It will only check for 80 port, whether it's open or closed. Or I can check multiple ports. I want to check 80 open, 443 open. It will only check for these two only. Or I can do in entire subnet. So it will check for these two ports only for the entire subnet. Yeah, so these are different variations. Like maybe I can check the OS detection, something like this. I'll give IP. So this will scan this IP. It will tell me which operating system is this device has. So let's see, after this we'll try. Or I can give the entire subnet, will scan all the computers, and it will tell me which device, which device has which operating system. If it can detect. If it can detect, of course, we don't know, but it does its best guess. Like it tries to find it which operating system they use. So that is one. Yeah, similarly, there are a lot more commands actually. I think you can try cheat sheet. So there are a lot more commands to detect so many things. I can see this we already know, this we know. Fast scan, fast 100 common ports, top ports. It will scan only 100 top ports, most used ports. Aggressive scan. Aggressive scan means combination of many things. OS detection, we just know. So these are different things actually. You can try if you have interest. We'll see NSC later. NSC is a scripting. Mostly to execute some scripts. So mostly these are still running. Yeah, you can try all these things.